All right, talking about inverse functions. All right, so inverse functions have this property. It says, write simplified expressions for these two things in terms of x. This isn't any different than the composite functions we just got done doing. So what we're going to say here is f of h of x. Well, that would mean this gets plugged in here. So let's go ahead and write that in. Cubed root 9. And I'm going to need parentheses. I need a fraction. I need the exponent, right? A lot going on here. 9 and then plus 4. Okay, and let's do the same thing down here. Plug f of x into h. So now I've got this whole mess. I need a root. 9x plus 4. All of that gets plugged in to the third. Finish this thing off, minus 4. By 9. All right, so now, are they inverses? Well, here's what we can do. All right, so they're inverses if this can all be simplified down to x. And if this can all be simplified down to just x. So that's the question. Does it equal x? So let's do this. Let's start with this first one here. Okay, if we're doing order of operations and we're trying to simplify this monstrosity, that's to the third over 9 plus 4, right? We need to do what's in parentheses first. So the innermost parentheses says start right here. Right, now we can't simplify anything there, but we can then multiply. So since there's no exponents, right? So let's multiply 9 over 9. Well, 9 over 9 is 1. So then we're left with this. Now, if we notice, there's nothing to distribute to these parentheses, so I really don't need them. Those parentheses, that is, still a cubed root. But then these two add up to 0, and then we're left with the cubed root of x cubed. So everything is undoing everything, right? This was divided by 9 and times 9 now. This was minus 4, and that's plus 4, and this is cubed, and that's a cubed root. But the thing we have to watch for is the order in which it occurs, okay? Now, if I did it right and I get x for this, all of that is correct, and I worked it all out, then, yeah, it's going to be invertible, right? It has an inverse. So I'm just going to delete both of those. Are they inverses? Yes. If the first one is correct, then the second one is also x. The first one is x, I should say. So is the second one. The inverse in one direction means that the other one is also the inverse. All right, let's try a different one. If I'm plugging this whole fraction in here, so let me do it in this order. Let's do this first one without working it out, or without plugging in the same way I did a second ago. So it says take h of x and plug it into g. So now I'm going to say 5x minus 8, yada, 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 plus 8 all over 5. All right, now you might be tempted to say, oh, yeah, this is easy, right? These undo each other. They undo each other. You're left with x. Wrong. Way wrong. All right, so remember, we should order of operations first. So this becomes 5x minus 40, and then plus 8, and then divided by 5. Well, this is an issue because these two are no longer opposites. So this becomes 5x minus 32 all over 5. That's our answer. Can't be simplified. So that does tell me right away that these two things are not inverses. So I can go ahead and say, no, they're not inverses. But I do have to go through the work of trying to figure out this second part. So now I'm going to have to plug in g of x into h. So g of x into h. So let's work that out real quick. X plus 8 over 5, then minus 8. If I want to combine fractions in here, I'll have to have a common denominator. So I'm going to have to rewrite 8 as 40 over 5, because 40 divided by 5 is 8. I want these two to be the same, the two 5s. Then I can say, all right, 5 times x plus 8 minus 40. I can combine them into one fraction. Put it all over 5. Now we can say, all right, times 5 divided by 5. That cancels. And we can simplify the top into x minus 32. Whew. So these are not inverses. Right? So we got to be careful. We had one that was an inverse, one that isn't an inverse. The order matters. Okay? The second assignment here is talking about build the mapping diagram to see if these two things are inverses. Determine if f is invertible. Okay, so let's build this mapping diagram. Let me zoom out here a little bit. So A goes to 1. B goes to 25. I'm just reading the table. C goes to 4. D goes to 4. And E goes to 25. All right, so here's the way we interpret whether or not it is invertible. Take a look over here at the second circle. Let's start from there. And let's say I asked you, hey, go to number 1. Where did this come from? Well, you could answer 1 came from A, right? What if I say go to 4? Where did 4 come from? Go back to where you began, right? So if I go back, well, there's two different answers here. I cannot say for certain which one of these I started at. It's either C or D. And I could do the same thing for 25. 25 had B or E. So is this invertible? No. So whenever you cannot answer that question clearly with only one answer, it's not invertible. That's because there's more than one thing leading to 4. There's more than one letter leading to 25. Now let's do another one of these. All right, so A to 120. Back up. B to 6. C to 24. D to 2. And E to 1. Let me back up there. Make sure you get them lined up. Don't be off by a little bit and miss it. If I look down through here on the right, the range, right? Not the domain, but if I look at the range, everything in the range only has one direction I can go, right? 1 goes to E, nothing else. 2 goes to D, nothing else, and on down the line. This is an invertible function because I can say, all right, I can invert my direction. I can say, what direction, where did this come from, right? 1 came from E. That's an invertible function. All right, that's all.